Okay, now let's go back to where we were. Okay? So it's very simple. We start with a trapezoidal graph. We figure the slopes. We figure the areas. And now we're looking at rate of slope change, right? So the question that we have is, between this trapezoid and this one, at what rate does the slope change? Well, you know, if you calculate the rate at which something changes, you're going to divide the change in that thing by the change in something else, right? So the first thing we want to do is figure out how much the slope changes from here to here. And we ran into a little bit of uncertainty on how you get the change as you go from here to here. What mathematical operation do you use? Because once you know what mathematical operation you use, you can easily calculate it because you have the numbers, okay? And we established with the example that, okay, if you have the temperature early this morning and the temperature now, what's the change in the temperature?
No.
Well, you know you're going to subtract. Do you subtract the morning temperature from the temperature now, or the temperature now from the morning temperature?
Now by morning.
Okay? Yeah, because if the temperature goes up, then we're going to get a positive result, right? It means the temperature now is greater than the temperature this morning, so if you subtract the morning from now, or do now minus morning, you're going to get a positive number, and that's going to agree with the fact that the temperature went up. You think it through. And if the temperature goes down, does the calculation still make sense? It does. So the change in any quantity is the final value minus the original value. It's an incomplete statement, but you understand what it means. Okay? And I'm not going to confuse it with a lot of words to make it precise, because I think we all understand what it means. And if you don't, make sure you ask me. I can put more words around it. I'm not sure that would help, but clarify it a little further, give you examples. Okay? A few examples really is enough. Okay, so anyhow, we have to establish this. We have to understand this. Okay? And we talked about it before, at least once, and I think twice. So make sure you lock it in now. So, okay, the change then is what?
-3/2 minus 3/4.
Yeah. Now, often these things are going to be complicated fractions, and you're not going to actually do the fraction calculations because in most cases nothing's going to be exact anyhow. If you're dealing with exact numbers, though, you want to do the fractions. You don't want to round them off if you want to get exact results. And if you do round things off, you got to round them off with enough significant figures that you don't mess up your results. Okay, so anyhow, there's your change. And of course, that's -9/2, isn't it? Because this is -9/4, sorry. This is -6/4, and this is -3/4, which gives you -9/4. Okay, so the rate of change of the slope, you divide this by the length of the interval. Because this slope most likely applies at the middle of the interval. You know, if you have an actual curve, chances are the slope of the curve at the middle of the interval should be pretty close to the average slope on that interval, if you use a small enough interval. And similarly here. So it's like you go from the middle here to the middle here, which of course, how far is it from the middle here to the middle here? Well, all these intervals have the same length, right? So if you go from the middle of an interval to the middle of the next interval, it's still going to be 4. Okay? So, the rate of slope change is the change in slope over I'll call it a subinterval, the length of the subinterval in your partition, right? In other words, in this case, 4. Okay? So we get negative 9/4 divided by 4 that's all sloppy. And that's negative 9/16. And we then note this, right above this point where the slope changes, we write our negative 9/16. I put a couple of dotted lines down here to show that that's where that rate applies. Okay? And then you do the rate here and here, which I'm going to just give you for homework. There's a detailed way you calculate the rate of slope change. Okay? Now, accumulated area is much simpler. So,
change
we'll go green
the
here.
slope because it's final minus original, so it can negative 4 minus 3 over 4, and that comes up to negative 9 over 4. And then rate of slope change is the change of slope over length of slope term interval, and that's 4.
So there's 4 different rules. That's why we're
Yeah, so
trying
you count by 4, 4, 4, 4. And like if you're going from midpoint to midpoint, it's still going to be 4.
Okay, the accumulated area, the first accumulated area is 34. Where did I get that number?
first.
It's your first area, right? So, the first accumulated area is 34, and I want a different color, but one that we can see. Okay, so in parentheses, I'm going to put 34. Then I'm going to put 34 plus 28, which is 62, right? Check my arithmetic. A little bit hard to squeeze it in. Okay? And so forth. Now, I don't have a lot of room to put these in, but it should be obvious what I do next. In other words, I take this area, and that's how much area I have through the end of this trapezoid. Then I add this area, and that's how much I've got here. Then I add this area, and that's how much I've got from here up through here, right? Accumulated area. We're accumulating area as we go to the right. So the last accumulated area is going to be the total area under these trapezoids. Any question? That should be very straightforward. So we'll have a video on rate of slope change and accumulated area, and we'll be seeing over the next couple of days how we apply these things. First, we want to get the operation down. And it's a simple algorithm, simple set of steps that are always the same. Okay?